Here's 5.2, day 2. We are going to focus today on graphing some functions and finding the axis of symmetry, the vertex, and converting factored form equations into standard form. Tomorrow we'll cover the continuation of this lesson where we're going to find what the y-intercept is and being able to graph the function completely. First slide, just go ahead and write down what the topic is. You don't need to write down what the objective is. Okay, next slide. The top half of this slide I don't want you to write down. It's already in your notebook. Just to review the three different forms of a quadratic function. The top one is what we call standard form, ax squared plus bx plus c. The blue form is what we call factored form. And then the green is the vertex form. We'll refer to these in this lesson. We're going to move down to the first example that we're going to work on together. So I do want you to follow along with this problem and write it in your notebook. We're going to convert this factored form equation to standard form by FOILing it and then identifying the a, b, and c. As we move through this lesson, the a, b, and c will become important to us. Today we're just going to identify them. So we're going to multiply x minus 3 and x plus 7 together by FOILing. So we start by distributing the x to the x in the second parentheses, and then the x to the 7. So x times x is x squared. X times 7 is 7x. So that takes care of first and outside of FOILing. Now we're going to distribute the negative 3 to the x and the 7. So negative 3 times x is negative 3x, and then negative 3 times 7 is negative 21. What will happen is you will have like terms with the 7x minus 3x. So the final equation of the function is x squared, 7x minus 3x, combined to 4x, and then minus 21. It also asks us to identify the a, b, and c. So notice this is standard form. So the a comes in front of the x squared term, the b comes in front of the x term, and then the c is at the end, which is our constant. So here is our a, which that coefficient is 1. There is our b, which that coefficient is 4. And then our constant c is negative 21. Let's do the second example. You do not need to write this example down. We'll just work on it together. So we have a function, but now there's a 2 in front of it. So we're going to wait on distributing that 2 through. We're going to just go ahead and FOIL the 2 parentheses first, and then distribute the 2. So here's my 2, and now I'm going to FOIL. So I'm going to distribute, excuse me, I'm going to distribute the x to the negative 4, and then the x to the 3x. So x times negative 4 is negative 4x. X times 3x is 3x squared. Then we next distribute the 1 to the negative 4 and the 3x. So we get 1 times negative 4 is negative 4, and then 1 times 3x is 3x. Now we're going to go ahead and put this parentheses in standard form and combine like terms. So I still have the 2 in front. Now my highest term in that parentheses is 3x squared. And then I have two like terms, the negative 4x and the 3x. Negative 4x plus 3x combines to give us negative 1x or negative x. And then we have minus 4 at the end. Now we're going to continue the problem by multiplying the 2 to all three terms in the parentheses. So distributes through. So 2 times 3x squared is 6x squared. 2 times negative x is negative 2x. And then 2 times negative 4 is negative 8. Here is our final function in standard form. And then it asks us to identify the a, b, and c. So our a is 6, our b is negative 2, and our c is negative 8. All right, we're going to move on to the next topic. Finding the axis of symmetry for a parabola. I would recommend that you write this slide down. The key points are going to be down below. So the topic is finding the axis of symmetry. What the axis of symmetry is it's an imaginary vertical line in the middle of the parabola. What the equation is going to look like is x equals k, which is some constant number. What I do want you to write down is how do you find the axis of symmetry? So the first thing is finding the axis of symmetry given x-intercepts. If you have two x-intercepts, so those are where it crosses the x-axis, you just find the halfway point between those two x-intercepts with the midpoint, and that's where your axis of symmetry is going to be. I'm going to show you some examples on the next slides so you can visualize it. The other way is if you only have one x-intercept, it'll be just at that x-intercept place. The other way to find the axis of symmetry is if you're given an equation in standard form. So standard form is y equals ax squared plus bx plus c. The formula that we're going to refer to a lot in this section is this formula, x equals negative b over a. So I'll give you a little bit of time to write this up. So again, this is what I want you to write down from this slide in your notes. All right, we're going to move on to some examples. These two examples I don't want you to write down in your notebook. So we're going to find the equation for the axis of symmetry for these two diagrams. So example 1 on the left. The picture is a parabola that opens up and it has an x-intercept at 1, 0, and then another x-intercept at 7, 0. To find the axis of symmetry is we're going to split that 1 and 7 in half. So we're going to find the midpoint. So I'm going to add 1 plus 7, which is 8. And I'm going to divide it by 2. So the value is 4. Then I go along the x-axis 4 units. And now what the axis of symmetry looks like is an imaginary vertical line running through that parabola right there. So the equation that we say is x equals 4 is the axis of symmetry. The second example, again, don't write this down, we have one x-intercept. The parabola opens down, and the x-intercept is at -3, 0. So now we just split this parabola through the x-intercept at -3. So the equation for this parabola is x equals -3. I'm going to stop the recording and it'll be a part 2.